Right, 8-1, we are in our new unit. Our unit is circles. Today's date is the 26th, 2/26. Let's go to 2/26. You're trying to trick me. Yeah, so arc measure. Today is just looking at the outside of the circle. We have a lot of vocab to get us started off. So what do I mean when I'm talking about arc measure? Arc measure is just the measure in, like the angle, I guess, the measure in degrees, how many degrees have I gone around the edge of the circle. So it's the measure. And we'll put in degrees. Of the arc. And whenever I say arc, I am talking about the edge of the circle. So far, so good. We're all taking nice, awesome notes. There we go. Is there anyone else that's missing notes? No? All right. So, arc, yes. My handwriting will slowly improve as I get used to writing with the Mimeo. All right, arc length. Instead of being the measure, this is going to be the length of the arc. So this is going to be the length. And as you can probably tell by the title, we are not talking about the length of the arc yet because we're only doing the measure in this lesson. I just want to get this vocab out of the way for next lesson so that we can just review it. All right, so central angle. This is the angle in the center of the circle. It's pretty self-explanatory, but if you look down here, if I draw a line from A to P, a line right here and here, that is a central angle because the angle is in the center of the circle. So it's the angle in the center. Angle in the center. If you're rolling your eyes because that's so explanatory, I will tell you this. Eventually, we're going to be having lots and lots of angles on the outside of the circle, on the edge of the circle, so that does become important later on. All right, minor arc. Minor arc means it's a small arc. So we'll just say small. When I say small, what I generally mean is less than 180 degrees. So if I'm less than 180 degrees, I'm going to call that a minor arc. So then, by that logic, what is a major arc? Colby, can you hand these out for us? Quite raised hand. What is a major arc? Martine. Yeah, so it's going to be greater than 180 degrees, and we'll call that big. Thank you, Martine. You can turn in your card once Colby hands that out to you. All right, and same rules as before. If you have turned in your card, wait for everyone else to turn in their card so that everyone participates, and then we can participate multiple times. Yes?
So once if it's below and once if it's above?
Yes.
What if it's at?
At 180, you can just call it an arc. That's a good question. That's kind of a philosophy dilemma, like you could call it both or neither, I don't know. So talking about arcs. So how do I identify this arc? Let's work on the notation of that arc. So I need to say the measure of that arc. So I'm going to use the symbol M just like we've done before, like the measure of angle, blah, blah, blah. This is going to be the measure of arc, blah, blah, blah. The way that I say this is the measure, and now I need to say arc AB. Technically the measure of minor arc AB. So I'm going to say measure of AB. AB refers to this arc AB, and to make sure that you know it's an arc, not a line segment, not a line, but an arc, you do this symbol over it. A little rainbow. I read this as the measure of arc AB. We're all going to do this like we're in kindergarten, and we're going to repeat after Mr. Sindel. Again, this is the measure of arc AB. Are you guys ready to do this? On 3, we're going to say the measure of arc AB. 1, 2, 3.
Measure of arc AB.
Yeah, there it is. Samantha didn't do it. All right, so this one is a little bit trickier because now we have multiple letters. So you need at least 3 of the letters when you're talking about multiple points. Or you can somehow say minor arc, and then I can kind of tell what you're talking about. Generally speaking, this is a more confusing case, so use at least 2 letters. If I use FEC, that's this other arc. If I use FAC, then that's this arc. Or I could do FBC, that's this arc. So you can do F and C, and you can choose, it's your choice, you can do A or B. You almost never will do 4 letters, you'll only do 3. So this one is going to be measure of arc F, and I'm going to randomly choose B, and then C. Because this one is a little bit more confusing, we'll use up to 3 letters. And I read this as the measure of arc FBC. Technically, it's a minor arc because it's slightly less than 180 degrees. If I were to look at this central angle, this angle right here is slightly less than 180 degrees. Remember, 180 degrees would have been a straight line. All right, quiet raised hand. How do I do this one? You know enough now to be able to actually use the notation. What is this arc? I see 1 hand, 2 hands, 3 hands. Lorea, go for it. There it is. That is one possibility. Go ahead and hand in your card. I can actually take it since I'm up and moving. Whoa. Someone else do another one. What's another possibility? Go for it, Beverly. Measure of EFC? EFC, measure of arc EFC. There it is. Yeah, thank you. You did not get your card? Oh. Martine, did you already hand in your card? Cool. All right, so we have some notation now. It doesn't really matter what middle point you choose. This one was a major, this one was a minor, this one was minor. Let's move on to actually measuring the arc. So this is what some might call a theorem, but if I draw a line segment between A and P, go ahead and just sketch a line. When I say sketch, I mean don't use a ruler. Don't use a ruler, just go ahead and make your best straight line between A and P. Because I have technology, I think I'm going to actually be using the technology to make my line roughly straight. So make a line between A and P and B and P. We have some perfectionists in the crowd, but you don't have to use a ruler again if you don't want to. So the measure of this arc AB, let's write this down. The measure of that arc AB is equal to the measure of the central angle, is equal to the measure of the central angle, and I'm going to call that angle APB. The measure of angle APB. So if this angle right here was, I don't know, 20 degrees, then the measure of arc AB is 20 degrees. So here's a thoughtful question. If I look at this whole arc length around this entire circle, what is the maximum number of degrees that this entire arc measure could be? Could it go up to 1,000? Could it go up to 1,000,000? What is the maximum amount that I can go going around the circle once? Quiet raised hand. Brian. 360. There it is. Yeah, card. 360 because I only have 360 degrees around a point. We've already defined that. Good job. So you have a maximum of 360 degrees. Do I need to say anything else about this? I do want to make this note. I want to say that this angle here, it has to be, who can use our vocab word? The vocab word that we defined up above. Quiet raised hand. It has to be, it starts with a C. It has to be a central angle. Write it down. This has to be a central angle. If this angle, for example, was, I don't know, I'm just going to randomly do something wrong and I'm going to undo it just to show you. If this angle was somehow, I had a point over here and I had a line that came from both points, this angle doesn't work because it's not a central angle. Don't use that angle. It has to be the central angle. Eventually, we are going to be seeing that type of angle. All right, let's try one. Try an example. Also, card. Put it there. Perfect. All right, so, ooh, this is going to be hard. Can anyone remember how to pronounce these guys? I need a reader. Quiet raised hand. If you haven't participated already, who can read this one? Anna, go for it. Diameters.
What is the arc measure in degrees of the arc?
Well said, yes. All right, so the arc that we're trying to find is clearly this minor arc BD, because it's labeled X and it's highlighted. How do I find that measure? Any ideas? You can raise your hand with a card, or you can raise your hand without a card. I want to see how many people actually know this. I want to try to choose someone that has a card. How am I going to find this measure? Well, again, we need a central angle. We don't have that central angle. But somehow we have to use the information up here. India, go for it.
So, I can see that it's the line segments go to make an X.
Okay.
And since one of the buttons is 120 degrees,
125.
125.
Yep.
I'm not sure what it was called, but you translate it over to the other side, like corresponding.
So this angle is going to move over there?
Yeah, because it's the exact same way it like that.
Okay. Yeah. So you're going to say that this angle here is therefore 125. And then what are you going to do?
And then since the measure of the arc BD is equal to the central angle, the arc BD is 125.
There it is. Yeah. There's our answer. X. And I can actually say, I don't have a Command Z button yet. I need to set that up. But my measure of arc BD, or I can say the measure of X, whatever you want to do. I'm going to say BD to be more precise. Measure of arc BD is equal to 125 degrees. 125 degrees. India had it correct. This is 125 degrees for this central angle here. But she couldn't remember the rule. She said you kind of translate it and you're correct, but who can remember the rule? What's the rule that says if I have two lines or line segments, I can say that this angle and this angle are the same? It starts with a V. Raise your hand with a card or without a card. I need to see how many people remember this. So if you have your card, you'll hold it in your hand as you raise it. Oscar, go for it. Yeah, vertical angle. So let's go ahead and write that as some review. These two angles here, draw a line up here, line up here. Those two angles are called vertical angles. And vertical angles are always congruent. Thank you, Oscar. Can I have your card? Thank you. Perfect. Perfect. Example 1. Any questions before we move on to the back side? Let's flip it over. All right, we're on example 2 now. Again, AC and BD are diameters, because sometimes it might look a little bit off, but I'm telling you, it is in fact the case that line segment AC and line segment BD are diameters. How are we going to find this arc AE? How are we going to do it? So I want to pause for 60 seconds so that everyone can have time to think. This is going to be a think, pair, share. You're going to think by yourself, and eventually you're going to pair up with people around you, and then you're going to tell me the answer. All right, it's that time. Again, quiet raised hands. I'm trying to look for those people that still have cards. How did you approach the problem? I don't care what the answer was. How did you approach the problem? Quiet raised hand. I still see 1 card, 2 cards, 3 cards, 4 cards. Who wants to share how they thought about the problem? I only see 1 hand. You can raise your hand if you don't have a card too, if you want. Go for it, Sam. You can come out to the board with me too if you want. No? This angle right here, 105?
No. Yeah. It's equal to 105.
Oh, so this whole angle here is 105.
Yeah.
Why?
Good question. Moving on.
Okay.
And then you subtract 105
Minus
55
to get?
to get 50.
Oh, to get that angle. Okay.
And then you add those together.
If these two angles were added together, it would equal that one?
Yeah.
Yeah, okay, nice. Cool. How many people by show of hands did it that way? Okay. Is there any other way that was able, or another way to do this one? Yeah, Martine, go for it.
So I did it, but mine was longer.
Okay, how'd you do it?
So from the BC and CD, I got 180 for that whole angle.
Okay, so this whole angle is 180 degrees. Okay. And then?
And it was 75 for CD.
75 for CD, so you subtract from 180, okay? And 180 again?
Yeah, or 75 on AB.
Oh, okay, 75 again. Did you use vertical angles or did you use the fact that they're 180 degrees in it?
Did 180 on both.
Okay, another 180.
And then I just added what I had together and subtracted it from 360.
Whoa, okay, so you added all of these angles together and labeled that one x, added them all together, set it equal to 360, solve for x. Very nice. How many people did it that way? Too long? How many people did it another way? How many ways were there to solve this one?
I did it a
Well, it
similar
was longer on there because I did see.
You did another way?
I did it a similar way, but what I did was after getting 75 on BPA, or CBP,
After getting...
I just did 180 with 75 plus 50.
So instead of doing 360 degrees, India just did all of that adds up to 180. That one's x, solve for x. Very nice. Yeah, there are multiple ways to solve these. So regardless of the way that you solve it, the answer should have been, shout it out, 50. Yep. So x, or I guess if I want to be a little bit more specific instead of just saying x, I can say that the arc of AE, the measure of arc AE, is equal to 50 degrees. We all should have got that. Cool. And we're on to example, yes.
I have a question about what direction you're supposed to label the arc in. Does it have to be like, 'cause it seems to go like AE or whichever one's on the left side more than on the right side. Could it be arc EA?
Arc EA is fine, yep. Yeah, so you can switch these letters. This is the same thing as saying measure of arc EA. There's no rule saying you have to go clockwise or counterclockwise. You can do whatever you want. Yeah, I mean, one is probably more standard, but it doesn't matter. It's all mathematically correct. Good question. All right, so we have our third and final example. By the way, tonight we have 2 homework assignments. One homework assignment is based on example 1 and 2, where you just find a number. The other homework assignment is like example 3, where you use equations. But they're solved using the same logic. It's just now a little bit harder to do the arithmetic, to do the algebra. All right, so example 3. I want everyone to stare at this on your paper, up here, whatever you choose. How are you going to approach solving this problem? I want the approach. I don't need you to do the math. If I call on you, I just want the approach. There's some people that still have their cards that need to come in. And Sam, I'm going to grab yours now. All right, once you think you have an approach, go ahead and raise your hand. Let's go ahead and pause so that more people can have some time. Quiet raised hand. Who has a strategy? Again, I'm calling on you. You don't have to do the math. I want the strategy. You have your card? Whew, there it is. Yeah, Colby.
Set it equal to 360 degrees.
Set what equal to 360 degrees? Everything. So I'm going to set 9x minus 7 equals 360 degrees. 13x plus 5 equals 360 degrees. Give me that look. Is that, so I'm setting each 3 of these individually to 360 degrees? No? What do you?
All 3 of them together.
Are you adding all 3 of these together? Oh, okay. So I'm going to add all of these together and set it equal to 360. Raise your hand if that was your strategy for solving it. Nice. Raise your hand if you had a different strategy for solving it. That's the only thing I can come up with also. So let's go ahead and do that. Let's add them together as a class. So 9x plus 7. That was this top angle. Minus 7. That's an extra credit point for Beverly. Keeping me on my toes. Good job. Samantha and Beverly both get XP if Samantha's telling the truth. 9x minus 7. I'm going to put parentheses. You don't need to put parentheses. I'm doing it so that you can see that that was one angle. I'm going to add that to another angle. I'm just going to randomly choose. Yeah. Okay. We can put degrees. I usually do the units at the very end, but I can do it right now too. 13x plus 5. And to make sure that we're up to Samantha's standards, we're going to put degrees as well. And no, it's good. We're being very precise. Math is about precision. Next, we're going to add 10x plus 10 degrees plus 10x plus 10, all of that degrees. So I'm going to add all of these together. And I'm going to set that equal, as Colby said, to 360 degrees. All right, let's do all of the x variables first. Who can help me with that? Who can add all of the x's? Who can add 9 plus 13 plus 10 in their heads? I'm looking for someone that has a card still. And again, if you have your card, raise your hand with the card in it so I can easily identify who to call on first. Go for it, Cheyenne. 32x. Yep, 9 plus 13 is 12 plus 10, or not 12, is 22 plus another 10, 32x. And add all the numbers together. I have a -7, I have a 5, I have a 10. Who can add all of our numbers together? Quiet raised hand. I think almost everyone has their card in. I think there's still one out there. Martine, go for it. 8. Careful there. How did you get 8?
It's -7.
So -7 plus 5. Yep, okay. I don't know what I'm talking about. 8. -7 plus 5 was -2. -2 plus 10 is indeed 8. Thank you, Martine. And that is going to be still set equal to 360 degrees. We can put all of this in degrees if we want to have our units there. You don't need to have units. I'm not going to take points away from units, but we'll be very precise in our notes. From there, what are we going to do to both sides? We're trying to solve for x now. Once we solve for x, then we actually need to find the measure. Beverly. -8 on both sides. -8, -8. What is 360 minus 8, Beverly? 352. Those 8s are gone. Now I have 32x degrees is equal to 352 degrees. I'm going to divide both sides by Ellery.
32.
32. Oh man, she already did that. 32, and it is indeed 11. That means x is equal to 11 degrees. Are we done?
No, you have to box your answer.
I do have to box my answer, but that's not my answer. I made a mistake here. I should have crossed this off because I was just copy pasted from last time. What is the arc measure in degrees of this arc? We haven't found this arc measure. We need to now use this x by doing what with this x? I have x. I need to do something to find this measure of the arc. Same people over and over. India, go for it. Yep, I need to plug it in. I'm plugging in for this x. This x is now 11. 10 times 11. Shout it out, everyone. 110 plus 10. 120 degrees. There is our final answer. So we're going to say that the measure of arc BC is equal to 120 degrees. Final answer, box it. That concludes the notes. Are there any questions? All right, go ahead and write your summaries now. We have paper homework, we have Khan Academy homework. You're going to choose whichever one you'd like.